In this video, we will learn how to perform diffusion simulation in Diffusion module. In this example, the two sides of the diffusion couple which have the same single FCC phase structure and uniform composition before diffusion. They are at point A, with 30% of chromium, 10% of iron and 60% of nickel. Point B, with 10% of chromium, 20% of iron and 70% of nickel. Now, let's open Pandat software, select Diffusion module, and create a workspace. This symbol represents that this is a Diffusion project. Then load database. Select iron chromium nickel database. Select all three components. The TDB viewer is open after the database is loaded. Not only thermodynamic data, but also mobility data are required for a diffusion simulation. Here you can see the MQ parameters from the mobility database. It should point out that these parameters can be seen in the TDB viewer if the database is an open-source TDB file. For a commercial database in PDB format, you cannot see the parameters. Please make sure to use a database with both thermodynamic and mobility parameters to perform diffusion simulations. Once the database is successfully loaded, the two Diffusion functions are activated. The left icon is for general diffusion simulation. The right icon is specifically designed for particle dissolution simulation. We are doing diffusion couple simulation. Click the left icon. Or go to the Diffusion menu. Select Diffusion Simulation. This is the general dialog for diffusion simulation. To carry out a diffusion simulation, we need to set up the composition and diffusion length of each region, the thermal history, and the boundary conditions. Before you define the conditions, it is better to first set up the proper units. Click the Option button. In this example, we use Celsius for temperature, atomic percent for composition, hour for time, and micrometer as length unit. Then click OK. This simulation will be performed for a diffusion couple which has two regions. Click Region 1, the background becomes light blue. Now we are setting the conditions for Region 1. First set up the region composition distribution, select Uniform, which means the initial composition is the same everywhere in Region 1. You can also set it as linear or get the region composition distribution from an input file. Such settings will be demonstrated in separate videos. Here we use uniform composition with 30% of chromium, 10% of iron. Then right-click the mouse here to set the composition of nickel as the balance. The length of this region is set to be 100 micrometers. Then click on Region 2. Set as uniform composition with 10% of chromium, 20% of iron. And then right-click the mouse here to set the composition of nickel as the balance, which is 70%. The length is 100 micrometers as well. Then, set the thermal history as isothermal heat treatment at 1000 degrees C for 1000 hours. Here we can also define the moments for profile outputs, which means we can choose to output the composition profiles at a number of intermediate stages. For example, here two intermediate stages are chosen, one at 200 hours and the other at 500 hours. Here, we want to mention that one must predefine the intermediate stages here before the calculation. Only the composition profiles at the predefined intermediate stages can be output. In the boundary conditions field, you can choose different upper boundary condition and lower boundary condition. Here we use closed for both boundary conditions, which means no mass exchange at the boundary between the diffusion region and the environment. We use the default planar geometry as the interface between the two regions. The automatic interface flux model is used. The number of grids is 100, which means the total diffusion length of this diffusion couple, which is 200 micrometers, is meshed by 100 grids evenly. The size of each grid will be 2 micrometers. After setting all the conditions, click OK and start diffusion simulation. This is the simulated result. This plot shows the concentration profiles of the 3 components within this diffusion couple. The dotted lines represent the initial concentration setup. The solid lines represent the concentration profiles after different period of time of heat treatment. Add legend to show the meaning of each curve. The results data are saved in these tables. If we want to plot the composition profiles of the 3 components at 200 hours only, double-click the Profile 200 table. Select distance as x-axis. Hold the Control key and select the compositions of the 3 components as y-axis. Then click this Create New Graph icon. The new plot shows the composition profile at 200 hours. That's all for this video. In this video, we demonstrated step-by-step to set up the simulation conditions for isothermal diffusion between a diffusion couple. We hope this tutorial helps you to learn the basic functions of Pan Diffusion module. Subscribe this YouTube channel and visit our website for more information about Pandat software and the latest development of our simulation tools.